This is problem number 89 of the 2012 AP Calculus exam. A particle moves along a line so that its acceleration for t greater than or equal to 0 is given by a of t equals the quantity of t plus 3 divided by the square root of the quantity of t cubed plus 1. If the particle's velocity at time t equals 0 is 5, what is the velocity of the particle at time t equals 3? So what we're looking at is the velocity function. And one of the things that we need to know is that the acceleration is equal to the first derivative of the velocity. And so we're given for that to be t plus 3 divided by the square root of t cubed plus 1. So our setup will look like this. We'll have v of 3, that's what we're looking for, minus the velocity at time 0, t equals 0, as being equal to the integral from 0 to 3 of the derivative of the velocity with respect to time. Now, the derivative of the velocity is the acceleration, which is the function that we have listed here, the quantity of t plus 3 divided by the square root of the quantity of t cubed plus 1. So we're going to substitute this in for the derivative of our velocity. So v of 3 minus v of 0 will equal the integral from 0 to 3 of t plus 3 divided by the quantity of t cubed plus 1 dt. Now, we were given one other piece of information, and that is the velocity at time t equals 0 is 5. So I can substitute in for this value. I'll have the velocity at time t equals 3 minus 5 is equal to the integral from 0 to 3 of t plus 3 divided by the square root of t cubed plus 1 dt. And we can add the 5 to both sides, and that will give us the velocity at time t equals 3 as being equal to 5 plus the integral from 0 to 3 of the quantity of t plus 3 divided by the square root of the quantity of t cubed plus 1 dt. And this is where we can put our information into the calculator. And we notice we have decimal answers, and so the calculator is going to be required here. So let's go ahead and pull up the calculator and turn it on. And we want to go to the y equals, and we want to clear it if there's anything there. Now I want to put in that function. And so for the y equals, I've got, let's put parentheses, t plus 3, in this case x plus 3, and divided by, and we're going to have the second and square root part, there we go, and the t cubed, or x cubed in this case, plus 1. And close the parentheses and hit enter and graph. All right. Next, we want to go ahead and clear that and go to Math 9, and that gives us our integral. And I'm going to go ahead and just put the variables, y variable, since we've already entered our function, and hit enter for the first one, put a comma, and put an x, put a comma, put a 0, and a 3 for our limits of integration. Now we could have just typed in for the Math 9 this function and not use it for our graph, but I like to get in the habit of using that variable and looking at the graphs just to make sure I haven't typed in something wrong, to make sure it looks reasonable. All right, now the only thing that I'm missing here is this plus 5, so I need to make sure that I add that plus 5 for my answer. And then we'll hit enter. And this will be our solution. This will be our value of v of 3. So let's go ahead and write that. And we want to round to 3 decimal places. So this will be v of 3, the velocity at time t equals 3, will equal 11.710 for our answer. And let's see which one that is. 11.710 is letter E. And that's our answer choice.